introduce Dr. Katie Young, and she can take it from here if you want to give a real quick bio, or let's just get right into it.
Okay. I'm going to, and of course my slides have frozen. That's what happened to us last time too. There we go. Okay, this is me.
Unmute.
This is me. This is my background. I'm an equine nutritionist with Kentucky Equine Research, and there's on my background, and there are all my horses. So that's as much as I'm going to give you as a background on me, so we can get right into the thick of things. Okay. If anybody has questions during the presentation, please go ahead. I believe, Lori, they go in the Q&A, or is that right?
So there's a Q&A spot where people can put in their questions. And if we don't get any questions, then I will ask some questions for people.
That sounds great. Okay, so tonight I'm just going to we're going to talk about carbohydrates, because metabolically there are a lot of issues with carbs, and horse owners are, of course, very concerned about carbs. Sometimes it makes sense, and sometimes it really doesn't make as much sense. But this is actually a very old cartoon that came out at about the time the Atkins diet showed up, but it's still appropriate today. Does your horse need a low-carb diet? Well, it depends. Are carbs unhealthy for horses? That is an absolute no. Carbs are not unhealthy for horses. There are times, though, we have to be careful about carbs, but to really get into it, we've got to understand what carbs are and what their functions are. Because there are times people are looking for a low or no carb diet for their horse, but when you start thinking about how do you eliminate carbs from a horse's diet, this is what you're left with. Does this look like a healthy meal for a horse? Absolutely not. Horses are herbivores. They eat plants. They have to have carbs. And there are different types of carbs, and that's what we've got to understand and figure out how to manipulate according to your horse's needs. If your horse is healthy, carbs really are not a big concern. But there are some metabolic conditions in which we have to be careful about some types of carbs for horses. So first, what are carbohydrates? There are two basic types of carbohydrates. There are non-structural carbs, which include starches and sugars, and then there are structural carbs, which are fibers. And that's where people, I think, a lot of times get a little confused, because structural carbs, the fibers, are absolutely essential in a horse's diet, and a lot of times people are scared of carbs but are going, we want a forage only diet, and the forage only diet is very, very high in structural carbs. So let's go a little bit deeper into the difference between non-structural carbs and structural carbs. But non-structural carbs are those carbs that basically are simple sugars in the horse's feed. There are non-structural carbs in every cell of all plants, and those non-structural carbs are broken down by enzymes that are produced in the horse. So in this category are sugars, simple sugars such as glucose, fructose, lactose, sucrose, which is it's a sugar, but it's actually comprised of glucose and fructose, and then starch, which is not a sugar. Starch is composed of a whole bunch of glucose molecules hooked together. But the non-structural carbs range from being almost non-existent in a grass hay diet to comprising a very high percentage of the total diet when a horse is on a high grain, low fiber ration. Oh, and my slides have stuck again, so I will escape again. Okay, structural carbohydrates, on the other hand, are those carbs that are resistant to a horse's digestive enzymes. The structural carbs occur in the cell wall portion of the plant, and they are fermented by bacteria living in the horse's gut, primarily in the hindgut, before they can actually be used by the horse. As a group, the structural carbs are called plant fibers, and they consist primarily of cellulose and hemicellulose. So just these are plant cells, and if you remember from way back from probably biology in junior high or elementary school, plant cells have a cell wall versus animal cells, which only have a cell membrane, no cell wall. The non-structural carbs, which would be the sugars, starch, and then another non-structural carb called a fructan, they pretty much live inside the cell. The cell wall is where these structural carbs are, the hemicellulose, the cellulose, and lignin is sort of considered a structural carb and sort of not, but it is completely indigestible even by microbes in the horse's hindgut. So non-structural carbs are inside the cell, and the structural carbs are in the cell walls. So starch is a non-structural carb and cellulose is a structural carb. And this slide shows the molecular structure of starch on the top and cellulose on the bottom. Gosh, they look a whole lot alike, don't they? Because they're both made up of glucose molecules. Glucose is a simple sugar that is found and used all over in the body. So the big difference why starch can be digested in the small intestine of the horse and cellulose cannot is because of the bond between some of the glucose molecules. And in starch, you see this bond is called an alpha linkage or an alpha bond. And in cellulose, it's a different linkage and it's a beta bond. Animals all make the enzyme that will break an alpha bond, but no mammals make the enzyme that breaks a beta bond. It requires bacteria to supply the enzyme to break the beta bond, and the bacteria are in the hindgut. That is why starch is digested and then absorbed as glucose molecules, the individual sugar molecules in the small intestine, and cellulose is not digested in the small intestine, goes right on back to the hindgut where the microbes then provide the enzyme to break that beta bond. And you can even see, even though as far as the molecular structure, the glucose molecules look very much the same in starch versus cellulose, but in the actual, when you look at starch and you look at cellulose under a microscope, you can see they look completely different. And it's just because of the difference in those bonds. So again, the non-structural carbs, which would be starch and sugars, are digested primarily in the small intestine through enzymes, and they're broken down into glucose. Glucose is absorbed into the bloodstream, and then insulin is released, which helps move the glucose into target cells. So that's the cascade. You get glucose from starch or sugars. It's absorbed from the small intestine into the blood. That stimulates the pancreas to release insulin. Insulin is a hormone that comes out and helps push glucose into the cells where it's going to be used. And it can either be used, it's going to be metabolized for immediate energy, or it can be stored in the liver and in the muscle fibers as glycogen, which is another source of fuel that is highly used by the horse. So non-structural carbs are quickly digested. The glycogen is readily available for high intensity work, and it is anaerobic type work. Structural carbohydrates, on the other hand, that's the fibers, again, cellulose, hemicellulose, lignin, but lignin is not fermented. Cellulose and hemicellulose pass through the small intestine into the hindgut of the horse, the cecum and the large intestine, and then they are digested through microbial fermentation. Starch in the upper gut is broken down into glucose. The fibers, even though they are primarily made of those glucose molecules, the microbes do not break them down into glucose. The microbes convert the non-structural carbs, the structural carbs into volatile fatty acids. Those volatile fatty acids can be absorbed from the hindgut and are a major source of energy, especially for maintenance activities. The VFAs are slowly digested. They're absorbed from the hindgut, and they provide energy for maintenance and low intensity work. The other thing to realize with fiber is that it is essential. Adequate fiber in the diet is critical to maintain a healthy hindgut, because that is basically the main source of food for the microbes in the hindgut. So if you want a healthy hindgut, a healthy microbiome, the horse has got to have adequate fiber, and of course, in normal situations, they get that fiber from the forage in their diets. So we talked about the fiber digestion in the hindgut, but you also do have some starch that is fermented in the hindgut. There is always some starch that passes through the small intestine undigested, and that will also be fermented into volatile fatty acids. Now, that is slower and less efficient than enzymatic starch digestion, getting to glucose. And you can run into problems if you get excess NSC or starch and sugars in the hindgut, because there is a certain amount that the microbes in the hindgut are kind of accustomed to, and there is a population of microbes that digest starch in the hindgut. But if you all of a sudden get an excess of starch in the hindgut, for instance, your horse gets in the feed room and eats a whole bag of feed, especially a high grain feed, and you get a whole bunch of NSC in the hindgut, then the bugs that usually are there and ferment the NSC suddenly have a lot more substrate to work on. So they just start going to town in fermentation. And one of the end products of the fermentation of starch or NSC is lactic acid. So when the bugs have a bunch of NSC, they increase their fermentation, you're going to see an increase in lactic acid, which then lowers the pH in the hindgut. And that acidity is toxic to the cellulolytic bacteria, which are the microbes that usually ferment the fiber. And those poor little bacteria that die due to the toxic situation release endotoxins from their cell walls. That can affect the permeability of the gut lining, and that can increase the risk for colic and laminitis. So that is a cascade that we see, again, if the horse gets into the feed room, and there are other situations you can have this happening. So in general, there are recommendations for how much starch can be in a meal for a horse to not exceed the maximums for several different situations. So the first one that I'm going to look at is to reduce the risk of starch overload to the hindgut. The recommendation is to limit starch or NSC intake to less than or equal to 2 grams per kilogram body weight per meal. So putting that in more usable or friendly terms, if you're looking for a max of 2 grams per kilo body weight per meal, how many pounds of feed would that be in a meal to make sure that you're not exceeding the limit? So if you look at oats, which are about 50% NSC, that's about, for a 1,000-pound or an 1,100-pound horse or a 500-kilo horse, you're looking at about 5 pounds of oats in a meal. And if you get much over that, you're going to exceed the limits for the upper gut digestion of that starch. Now, as the feed gets lower in NSC, you can safely feed a little bit more in a meal. So if you've got a feed, and this is a kind of typical formulated sweet feed that's about 35% NSC, you could feed about 7 pounds in a meal for an 1,100-pound horse without worrying about overloading the upper gut. If the feed is 27% NSC, you could go up to 9 pounds. If it's 17% NSC, we're up to 13 pounds in a meal. That's not even per day, that's in a meal. And this is, again, a healthy horse, and we're just trying not to overload the upper gut with starch and sugars. So if you get a low NSC feed that's 15%, the chances of overloading that upper gut are very low unless your horse gets in the feed room and eats a whole bag of feed, because that's going to be 15 pounds of feed. And all the way down to 10% NSC, that's a very low NSC feed, 22 pounds to overload the upper gut. So it's the point of this is to always take into consideration what is the NSC of the feed, and the lower you get, the more room you have to feed a little bit more in a meal. Now, what about green grass? Because we do know that horses sometimes colic and possibly develop laminitis when they're on fresh green grass. Well, it's actually kind of a similar situation. And the thing to remember when you're dealing with growing grass, or actually growing plants of any sort, plants make sugar. You've all heard about photosynthesis, where plants use sunlight, water, and carbon dioxide, and they synthesize sugars. And during the daylight, since they need sunlight, they're making sugars. And then when the sun goes down and it's nighttime, they actually use those sugars to fuel their growth. So they make sugar during the day, and then they use up their sugars to fuel their growth at night. So this is just plant photosynthesis. You've got 12 carbon dioxides and 11 waters in the presence of light, and you get sugar, which is basically glucose, and 12 oxygens released. The tricky thing is that growth is more temperature sensitive than photosynthesis. The plants can usually photosynthesize even when it's pretty chilly. But especially warm season grasses, when it's chilly, they don't grow. The cool season grasses can photosynthesize when it's quite cold, and actually cool season grasses can photosynthesize even under a thin layer of snow, but they're not going to grow at night. So when we have times of warm sunny days and chilly nights that we typically see in the spring and in the fall, the plants can keep on making sugars during the day, but they're not growing at night. And so the sugars are then stored instead of being used as fuel. The warm season grasses store their sugars as starch, and the cool season grasses store their sugars as fructans. Then the storage forms of the sugars can build up as spring or fall go on. You can end up with pretty high levels of soluble carbs, or NSC, in the pasture grasses. And those NSCs are going to be sugar, starch, and or fructans in the cool season grasses. Immature plants are higher in soluble carbs compared to mature plants in the first place, but then the buildup of stored carbs due to environmental conditions typical in the spring adds to the situation, and there have been levels as high as 40% dry matter of NSC reported in certain grasses, so that is pretty darn high. And going back, what's a fructan that I mentioned, because the cool season grasses can store their sugars as fructans, and those are part of the nonstructural carb group. They are oligo or polysaccharides that include short chains of fructose units with a terminal glucose molecule. And the fructoses are really not well digested and absorbed in the small intestine, because the fructans, like the fibers, like cellulose and hemicellulose, have a beta bond. So the fructans pass through the upper gut and get to the hindgut, where they are fermented. But even though they have a beta bond like the fibers, instead of being fermented like the fibers and producing the typical volatile fatty acids, they're fermented much more similarly to starch and sugars and produce lactic acid and gas, and they can produce acidosis in the hindgut, which is just, again, that acidic environment that's toxic to the cellulolytic bacteria and can cause colic and or laminitis. Keep in mind, the cool season grasses store sugars as fructans, and they can store more fructans than warm season grasses can store starch. So when you start worrying about NSC in your grasses, the warm season grasses tend to be lower in NSC, and they are storing starch and not fructans. So when you have that large soluble carbohydrate content of the lush grass, when it's not introduced gradually, like let's say you've kept your horses off the pastures in the winter, and in the spring you're waiting to put them back on until the grass gets nice and tall and healthy, because we all know horses can really destroy grass pastures. But if you do that and then just turn the horses loose on the nice green pastures, that change in soluble carbohydrate or NSC content can trigger colic or, again, possibly laminitis, because you've got a big slug of NSC that can overload the upper gut, or in the case of fructans, they're not digested in the upper gut in any case. So you've got a bunch of unfamiliar NSC in the hindgut upsetting the microbial populations. It may be more of a risk due to management sudden forage change, but environmental conditions can exacerbate this. The weather patterns, temperature, and rainfall. Again, when we have the warm sunny days and chilly nights, that just can set up situations for sensitive horses to develop digestive upset.
Katie,
Yes,
can we ask a question?
you bet.
So somebody has asked, back to the meal size, to the point of a meal size and the amount of NSC/meal, what should be the interval between meals, and how does 10% NSC hay fits into this rule?
At this point, the 10%, what we're talking about in regards to laminitis, in these situations, the hay really is not an issue at all, because the NSC of typical hays are not prone to cause laminitis in healthy horses. So the size of the meal, the chart that I showed really was just in a grain meal that can overload the upper gut. And then this is all about sudden changes to the microbes in the hindgut. And then as far as the timing of the meals, you want to spread the meals as far apart as possible and fairly evenly spaced. So if you have 2 meals a day, as close as you can to 12 hours apart. If you got 3 meals a day, closer to 8 hours apart, just kind of even spacing of the meals.
Okay.
So did that answer the question?
Yeah, I think so. If they want to ask something more, they'll probably put it in here, but I think to me it explained it. But
Okay.
you mentioned a healthy horse.
Well,
versus...
and we're going to get into the metabolic horses in a few minutes.
Okay.
And that's, yeah. So this is a healthy horse and an overload of NSC into the hindgut.
Correct. Okay.
That can cause the issues.
Okay. Let's move on.
Okay. Now, there are several different ways that you can get laminitis when you're dealing with green grass. Once again, the overload of soluble carbs to the hindgut. So, as I said, the sugars, the starches, and especially fructans can bypass the digestion in the small intestine and get into the hindgut where they're fermented. And more specifically, what's going on, the availability of soluble carbs allows increased population of lactate-producing gram-negative bacteria that rapidly ferment the carbs. And these are the bacteria. There's always going to be some population of these lactate-producing bacteria. But when the amount of soluble carbs in the hindgut stays fairly constant, then there's no big disruption to the total microbiota of the hindgut, because the microbes in the hindgut are amazingly adaptable when they're given time to gradually change and adapt their populations to the feedstuffs in the hindgut. It's when there are sudden changes that really shift, because the populations can shift very rapidly, but it's not necessarily a healthy situation. As I said, again, the lactate producing microbes can increase their populations very quickly, but then the results can be very devastating to the cellulolytic or fiber digesting bacteria. So we want all these shifts to be very gradual, which is one of the reasons horse people pretty much always know that when you make feed changes, you should make them gradually. And that's to allow the microbes populations to gradually shift to adjust to the changes. So again, the byproduct of the fermentation of the NSC is lactic acid. It results in a drop in the pH or hindgut acidosis. The decrease in pH results in the death of cellulolytic bacteria, the fiber fermenters, which release the endotoxins, reactive amines, and exotoxins. And for laminitis, these compounds are thought to adversely affect circulation, increase inflammation, and destroy lamellar basement membranes in the hooves, causing laminitis. Now, exactly what is happening between all of this mess in the hindgut and the hormones and other metabolites that are passing out of the hindgut into the system and travel down and cause laminitis, we do not know exactly what that cascade is. We just know that this is one way that we can certainly cause laminitis in the horses. There are other modes of action that may lead to laminitis, and this is the next one is when we get into the metabolic horses. This is what we're going to see also as a big cause of laminitis is insulin dysregulation. And in insulin dysregulation, if you have a horse that's insulin dysregulated on lush green pasture, there is a possibility that consumption of high sugar grasses can cause a rise in blood glucose, which triggers the release of insulin, which again helps regulate blood glucose by helping to push the glucose from the bloodstream into cells. If a horse is insulin resistant, the mechanism malfunctions, the blood glucose is not moved into the cells, then the pancreas releases more insulin, the blood insulin levels increase, and this hyperinsulinemia triggers alterations in blood flow to the hooves, boosts expression of lamella pro-inflammatory cytokines that activate inflammation, and then we alter the glucose metabolism within the hoof lamellae, causing laminitis. I will have more slides going through this as well, so I will explain it a little simpler and hopefully make it even more clear. So again, remember, growth is more temperature sensitive than photosynthesis. So in the spring and in the fall, we can get those situations that we have increased sugars in the grasses, and we can get the overload of soluble carbs causing laminitis. So what about forage management? So we try to keep this from happening. Horses maintained on pasture year-round usually naturally adjust to new grass as it gradually grows. Mother Nature is usually fairly kind to us in the pasture grasses start up slowly, and the microbes in the hindgut have a chance to adjust to the differences in the NSC content of those grasses. The problems are most likely to occur when fresh forage is introduced abruptly, so that's why we have risk management options such as feeding hay immediately before turnout, so you take the edge off their appetite, and they will hopefully not just go out and voraciously graze this fresh green grass. When you first turn them out, if they've not been out on green grass all along, then we suggest restricting the grazing time. So a possible schedule when you're just starting to turn them out on green grass is about 30 minutes of grazing once or twice a day on the first day of grazing, then increase that by 5 to 10 minutes per day until the horses are grazing 4 to 6 hours per day total. And at that point, the microbes in the hindgut should be adjusted to the amount of soluble carbs in the grass. For very sensitive horses, first, I say very sensitive horses, but actually for very sensitive horses, they may never be able to be out on green grass. But for sensitive horses, the least risky time for grazing is between 3 a.m. and 10 a.m. because that's when the plants are going to have their lowest sugar content because they've made their sugars during the day, they've used up their sugars during the night, and by 3 a.m. they should be pretty low in sugar, assuming that the evenings are or the nights are warm enough for growth to occur. And then I have a picture of a horse with a grazing muzzle, of course, because grazing muzzles can be a big friend if you've got a horse that is sensitive to the NSC in your grass. And another thing, representing Kentucky Equine Research, there's a wonderful product available that has some great research on affecting the acidity in the hindgut. EquiSure is a buffer and it's encapsulated and time released, so it actually is a buffer that makes it to the hindgut and helps buffer acid shifts when horses are getting out on green grass. So if you have horses that are prone to hindgut acidosis and you're worried about hindgut acidosis, EquiSure is a wonderful management tool to help reduce the risk of digestive disturbances. Okay, now we're going to get more deeply into the metabolic issues, which equine metabolic syndrome is characterized by insulin dysregulation, obesity, and a predisposition towards laminitis. So we can see dyslipidemia, hyperleptinemia, arterial hypertension, and inflammation all are associated with negative outcomes in the form of limiting performance, increasing morbidity, and potentially eventual mortality due to the predilection for these horses to become laminitic. So what are the major characteristics of equine metabolic syndrome? Well, one of the first ones is obesity. And that is tricky because not all metabolic horses are obese, but the majority of metabolic horses are prone to obesity. And you see accumulation of adiposity or fat, and that can be generalized or regional. You can see horses that have basically little fat lumps. It's regional adiposity, and it's not evenly distributed fat around their body. And in these horses, weight loss resistance is very common. You get these horses, they're very easy keepers. They put on fat, and it can be very difficult to get the fat off of them. Another major characteristic, and probably the number one characteristic that identifies these horses, is insulin dysregulation or insulin resistance. We called it insulin resistance up until a few years ago, and then insulin dysregulation is the term that is used now to describe this situation, and it's an abnormal insulin response to blood sugar. It's characterized by high resting insulin, high postprandial insulin, which is the blood insulin after eating, or insulin resistance at the tissue level. And then the other major characteristic for metabolic syndrome is laminitis. And we see hyperinsulinemia associated laminitis, or HAL, when chronically high insulin levels have adverse effects on laminar tissues, causing lameness and possibly classical laminitis. Genetic predisposition to equine metabolic syndrome is likely, but it's not the sole culprit. And the genetics for metabolic syndrome have not been identified at this point. And hopefully, at some point, it will. But it tends to be the breeds of horses that are known to be easy keepers, Arabians, ponies. But it's not the only thing, because we see metabolic syndrome in horses that you think that's not the type of horse. For instance, you don't usually see metabolic syndrome in thoroughbreds, but it's possible. We see metabolic syndrome in warm bloods. And again, it's tricky because some of these horses with metabolic syndrome are not obese, and you don't even necessarily realize it's going on until laminitis occurs. And metabolic syndrome, there are overlaps among endocrine disorders involved in metabolic diseases. So you see, there's these three circles. We've got horses, the top circle are insulin dysregulated only. So these are non-obese metabolic syndrome horses that are at a higher laminitis risk. We have obese metabolic syndrome horses, and those at a higher laminitis risk, but we also have horses that are just obese and they are not insulin dysregulated. They're just fat and they stay healthy being fat. Then we have PPID horses. We'll talk about those in a bit. The PPID horses sometimes are insulin dysregulated and sometimes not. So if you have an insulin dysregulated horse, an obese horse, a PPID horse, and put them all together, perhaps an obese PPID insulin dysregulated horse, that's that interlocking the piece right in the middle of those circles, that is a very high risk of laminitis. So the further you get out of the circles to the edge of the circles, the lower the risk of laminitis. So the more of these endocrine disorders you have going on at the same time, the more risk of laminitis you've got. The clinical signs of metabolic syndrome, and some or all of these may be present. If you've got obese horses, the clinical signs include insulin dysregulation, clinical laminitis, divergent hoof rings, which are indicative of subclinical laminitis, of course, obesity, regional subcutaneous adipose tissue deposits, that goes along with the just kind of lumps of fat in various places along the body. These horses often have a cresty neck, and the fat on the crest of the neck can actually get really kind of feels quite hard. You can see preputial or mammary gland enlargement with actually you can see there's subcutaneous fat there, and again weight loss resistance. In non-obese horses, the clinical signs would be insulin dysregulation, clinical laminitis, and again, the divergent hoof rings. And as I mentioned before, you can have concurrent diseases with pituitary pars intermedia dysfunction, or PPID, which used to be called Cushing's. The clinical problems may be historical or current. Some of these horses have some of the symptoms, but then it's resolved and you think that you're past the danger, but the metabolic syndrome is quite likely still present. It's just being managed. It is very important when managing horses, and actually all horses, healthy horses or horses with metabolic issues, to be familiar with body condition scoring, which is just a scoring system to help people objectively determine whether their horse is thin, just right, or fat. So the scoring system runs from 9, which is extremely fat, down to 1. 1 is emaciated, it's very thin, and in general we want horses to be a body condition score of about 5 or moderate. This chart is available on our website at KER.com, and again, I recommend you get used to this chart because quite honestly, body condition scoring is a system that I use more often than I use body weight for a horse. So it's helpful to know how much your horse weighs, but once you know how much your horse weighs, is that the weight they should be? Or is your horse fat and should lose weight? Or is your horse too thin and should gain weight? That kind of informs all the decisions on how much to feed and what to feed. But when you're dealing with a possible metabolic horse, you really want to be aware of their body condition score, because once they get beyond a body condition score of 6, which is moderately fleshy, then you run a much higher risk of running into metabolic problems and triggering, well, higher risk of triggering laminitis in a horse. The other thing to be aware of is a cresty neck score. As I mentioned before, especially with obese metabolic horses, the cresty neck score can give you an idea of how at risk your horse is. So this is a score that runs from 0 to 5. 0 is a horse that is really thin and does not have much of any fat or muscle along their crest. And then you can see 1 is no visual appearance of a crest, but there's a slight filling that you can feel with palpation. And on the horse's crest, you want muscle along the horse's crest. You want a top line, but you don't want a large amount of fat, because fat is also deposited along the crest of the neck. So a 1 has very little fat. A 2 is fairly healthy. You've got a noticeable appearance of a crest, but the fat is deposited fairly evenly from the pole to the withers, and the crest is easily cupped in one hand and bent from side to side. Then you get to 3, and you're getting a little higher fat level than we'd like to see. The crest is enlarged and thickened. The fat is deposited more heavily in the middle of the neck than toward pole and the withers, and it gives a mounded appearance. The crest fills the cupped hand and begins losing side-to-side flexibility. A cresty neck of 4 is where I start really getting worried. And this is a very enlarged and thickened crest. You can't cup it in your hand. It doesn't really bend well. You might start seeing the wrinkles in the fat. And then a 5, the crest is so large. I've only seen this a few times, but it permanently droops to one side. I've seen this more in donkeys. There is a bit of difference in breeds. For instance, in draft horses, the draft horses, you often see a crest that's a 4. And that's where those breeds tend to store the fat. I've seen draft horses with a cresty neck of 4, but the actual overall body condition is fairly thin, because they store fat in the crest, and they may have very little fat over their ribs or along their spine. So that is something to keep in mind. But a combination of body condition scoring and cresty neck score can give you a good idea of how risky your horse is at the moment for possible laminitis and metabolic syndrome. So insulin dysregulation or insulin resistance. This is just my little chart to try and really explain what is going on. So in a healthy horse, the horse eats NSC, which is sugars and starch. The sugars and starch are broken down into glucose, a simple sugar, and glucose is absorbed into the bloodstream. And that higher glucose in the blood stimulates the pancreas to release the hormone insulin. And insulin's job is to enable glucose to enter cells. And in the cells, it's either going to be used immediately as fuel or stored as glycogen, for the most part, in the muscle or the liver. In insulin resistance, you see that red X where over the arrow where the insulin is able to get glucose into the cells. So something breaks down. We don't know in all cases what's happening, but it breaks down and the insulin is not fully able to efficiently get glucose into the cells. So instead of the glucose being able to enter the cells, it stays in the blood. And you still have high blood glucose concentration, and the pancreas is stimulated to release more insulin. So that's where we see the high insulin levels in the blood, and we see the high glucose levels in the blood at times after meals when we would normally expect to see the insulin and the glucose back down to their lower non-meal stimulated state. So this is hyperinsulinemia, when we have that high blood glucose, high blood insulin. And what are possible causes of this? Well, genetics. We don't have the genetics identified, but there is most likely a genetic component, but it's not the only one. Obesity can help cause hyperinsulinemia because fat causes insulin resistance, basically. Lack of exercise, that can help cause insulin resistance. High dietary NSC with a horse that has some of the other issues going on. A healthy horse, high dietary NSC is not a big deal, but with a horse with a metabolic issue, it certainly can be. Corticosteroids can cause hyperinsulinemia and PPID. Some PPID horses are insulin dysregulated as well, and you see the hyperinsulinemia, and that can, in all these cases, the hyperinsulinemia can lead to laminitis. And of course, laminitis is one of the most serious consequences of metabolic syndrome. And laminitis results in a separation of the hoof, the sensitive laminae that hold the hoof wall to the sensitive structures in the hoof. Those laminae in laminitis separate. And so the hoof wall can separate from basically from all the tissue that holds the coffin bone in place. This causes excruciating pain and mechanical damage that at best requires special management and at worst is life-threatening. So metabolic syndrome lowers the threshold for laminitis and makes it easier to develop. And this is information from UC Davis, and the connection between hyperinsulinemia and the laminitis damage, lamellar damage could be via IGF-1 activation. That is one of the theories at this time, and that is actively being researched because we've been looking for exactly what causes laminitis for decades. And we're closer, but we don't have all of the absolute answers. But you can see in this diagram what happens when the coffin bone is separated from the structures that hold it in place. It can rotate downwards. And one of the interesting things that I learned several years ago, founder is a term that's commonly used for laminitis, but actually the state of founder is when the coffin bone rotates downwards. And the reason it's called that is because when a ship goes down, when a ship sinks in water and goes down front end first, it's called foundering. And that's what happens with the coffin bone. It rotates and basically founders. One of the things that I did want to point out is that the relationship between obesity and insulin dysregulation, because people think of fat as it's just this inert tissue that we all develop by eating too many calories, but fat or adipose tissue is actually an active tissue. And fat tissue in horses diagnosed with metabolic syndrome produced higher levels of certain cytokines or markers of inflammation compared to healthy horses. So that fat tissue is metabolically active. And so the conclusion was that regional fat cells themselves are contributing to insulin dysfunction in horses with obesity and metabolic syndrome. Again, there are some fat horses that are just fat. There are some breeds that just can carry excess fat and still be pretty darn healthy. But horses with metabolic syndrome are best to maintain not in an obese state. So the factors to reduce the risk of insulin dysregulation and insulin resistance, of course, number one is weight loss. And research has shown that just the loss of weight, particularly if the loss is fat, can increase insulin sensitivity. But you've got to be careful of how you affect that weight loss, because if you just start drastically cutting calories, then the weight loss can be some fat, but it also can be a lot of muscle. And a lot of times people think, well, I'm just going to get them to lose weight by cutting out all the grain or all the concentrate in the diet and just feed them grass hay. A lot of times they're not getting all the nutrients they need from just grass hay. And if, for instance, you're not providing adequate protein in the diet, then sure, you're going to lose a lot of muscle weight. And the muscles actually can be helpful in insulin dysregulation. So we want to have healthy muscle fibers. So we want to keep the horses on a balanced diet that provides all the nutrients, just reduce the calories to try to affect weight loss. Exercise is also an extremely important component because research has shown that exercise absolutely increases insulin sensitivity. Horses that are exercised, the glucose insulin response is more sensitive than horses that are sedentary. So if at all possible, affecting weight loss with lowering calories and increasing exercise is, of course, the most healthy way to reduce weight and reduce the risk of insulin dysregulation. And then limiting dietary NSC. Less dietary starch and sugars can reduce the risk of glucose intolerance in metabolic horses. The caveat is that glucose is an essential fuel for even maintenance activities. So putting a horse on a diet that has as basically, well, you really can't give them no starch and sugar because every ingredient, even grass hays, are going to have some starch and sugar. But we are seeing some situations in which the starch and sugar is so low for horses that we start seeing problems, especially in performance. So keep in mind that glucose is the only fuel that's used by the horse's brain. It's the primary fuel for feet. It is the substrate for glycogen, that fuel stored in the muscles and the liver. So if they're not getting adequate starch and sugars, they can't store muscle glycogen. And glycogen depletion causes lack of performance. So some of these, especially a high-level performance horse that the owner's trying to really back off on the starch and sugar, you can see a decrease in performance. And keep in mind that the dietary starch and sugars are the primary source of glucose. So general management of metabolic syndrome. Again, get the weight off. Control the concentrate and forage intake. So manage dietary NSC. And I've got some suggestions on what the levels of NSC should be for different types of horses. But for metabolic horses, you do need to manage it. Exercise if at all possible. When you have a horse that you suspect may be metabolic, keep them exercising. Try to keep them from gaining weight in the first place and try to maintain them at a healthy weight and exercise level and reduce the risk of ever even getting to laminitis. There are medications and supplements to hopefully help manage blood glucose. And for that situation, I would suggest you work with your veterinarian. I'm a nutritionist. I don't get into medications whatsoever. There are some supplements that might help. KER's EO3, which is a source of marine-based omega-3 fatty acids, can be helpful sometimes in managing the blood glucose levels. So there are some things that may help, but the big ones are getting the weight off and keeping the horses exercising. The European College of Equine Internal Medicine has come out with a list of some suggested management tools to use for metabolic horses. They suggest that obese horses should lose between 0.5 and 1% of their body mass. The weight loss can be achieved by offering a forage-based ration. Sorry, my words are starting to get messed up here. 1.4 to 1.7% of their body weight daily in forage. If a horse weighs 1,000 pounds or 450 kilograms, then it would be offered 14 to 17 pounds or 6.4 to 7.7 kilos of appropriate forage, see below, daily. And the below is forage containing less than 10% nonstructural carbs to limit increases in insulin. Forage analysis and hay soaking may be required to achieve this goal. So back to the question asking about the 10% NSC in forages, we're looking at that for metabolic horses, horses with equine metabolic syndrome, horses insulin dysregulated, and possibly PPID horses that also metabolic or insulin dysregulated. Now, if a horse or pony appears to have weight loss resistance, and that does happen, you got an obese metabolic horse or pony, and you cut down the calories, you cut down the total amount it gets, and they still don't lose weight, then you can reduce the forage to as little as 1.15% of their body weight. And again, if you can also exercise them, that will really help in your weight loss efforts. Oh, and my slides have quit. There we go. Now, so in general, nutritional management of metabolic syndrome. Restrict or eliminate pasture. Some of these horses are so sensitive that the NSC, yes.
We're still on the European College of, there we go.
Oh, did it move?
Yeah, it just moved now.
Okay, thank you. So some of these horses may be the metabolic horses may be so sensitive that they just can't even be on pasture, or the very, very easy keepers. You put them on any green grass and they gain weight, and I've heard it called, they get footy, they get a little sore. And in those situations, just eliminating pasture entirely. But if you've got a horse that is just an easy enough keeper that you can let them have some pasture access, then again, a grazing muzzle may be the best friend. For hay, then again, recommended less than 10% NSC. Slow feed hay nets are a great way to go, because that slows them down in eating their hay, because these horses, I'm sure any of you who have a metabolic, easy keeping horse, you give them their little bit of hay, you measure out how much hay you need to give them per day, and you give them their amount, and they just devour it. It's gone in 30 minutes. And then you increase the risk of gastric ulcers, because they have all this time with nothing in their stomach or in their hindgut. So slow feed hay nets can be very helpful in taking the smaller amount of hay and making it last a long time. Another thing you can do is soaking your hay, because when you soak the hay, it removes some of the water-soluble carbohydrates, the NSC. You may have noticed I jump around going between NSC and soluble carbs, which basically mean the same thing. But these are carbs that are soluble in water. So if you soak your hay for 30 minutes in hot water or 60 minutes in cold water, that can reduce the NSC by up to 30%. Be aware that when you do this, you do need to pour the water off, because the soluble carbs have dissolved into the water. You also are going to be losing some of the soluble proteins and some of the soluble vitamins and minerals. So when you soak your hay, that hay has less nutritional value. So it's important to make sure that you are coming back with something to replace the nutrients besides NSC, the protein, the vitamins, and the minerals, to make sure that your horse is getting everything it needs. Alfalfa can be used for metabolic syndrome horses, but alfalfa tends to be low in NSC, but it's also higher in calories in general than grass hays. So I have alfalfa with a question mark, because for an easy keeper, then alfalfa may not be the best choice of forage, because it's higher calorie than grass hays. So that's something to be aware with your own horse. There are some metabolic horses that are hard keepers, and in those situations, alfalfa may be an appropriate forage for them. And then feed. I usually recommend, even for easy keepers, you come in with a ration balancer to, again, provide protein, vitamins, and minerals that are typically missing in forages. If the horse is not as easy of a keeper, then you're going to want to come in with a concentrate feed that you can feed to provide adequate calories to maintain an appropriate body condition. And in that, maybe less than, if it's a very sensitive horse, maybe less than 12% total NSC. It depends on how high calorie that feed is, because if you have a very high fat, high calorie feed, then you're going to feed a lower total amount of that feed to get the calories. So it may be able to be a little bit higher NSC, because it's not the 12% NSC, it's actually how many grams of NSC the horse is eating, per meal or per day. And so we want to keep the grams of NSC at a relatively low rate. So again, a hard keeper, a low NSC, high fat feed may be very appropriate. The other thing is that small meals. It's been seen in research that even when the total meal provides the same amount of NSC, the smaller meals create less of an insulin response. So if you take however much per day and break it down into smaller meals, you'll get lower insulin responses to the meal, and that can be helpful for the metabolic horse. And you've already seen my starch limit per meal chart, but now we are, instead of looking at an overload of the hindgut, you can see down underneath the chart in blue, it says to reduce risk of exacerbation of insulin resistance. In general, the recommendation has been limit starch intake to less than 0.3 grams per kilo body weight per meal. So in the little blue row now, or column, that's 0.3 grams per kilogram body weight per meal, and the number of pounds of different NSC values of the feed for an 1,100 pound or 500 kilo horse. Again, oats are high NSC, about 50%. So to reduce the risk of exacerbating the glucose insulin response for an insulin dysregulated horse, you can only feed about 0.7 pounds of oats in a meal. And oats are not a balanced feed anyhow, so this is just kind of for reference. I would not recommend that anybody's just feeding straight oats. For a typical formulated sweet feed, we're talking about 1 pound per meal for an 1,100 pound horse. So if you have an insulin dysregulated horse, you're not going to be looking at a sweet feed. If you go down to the 15% NSC or the 10% NSC, then we're getting to amounts of a feed that are going to be more typical for a meal for an 1,100 pound horse. 15% NSC, we got 2.2 pounds in a meal. 10% NSC, we got 3.3 pounds in a meal. And then you can give, 2 meals a day, possibly 3 meals a day, depending on the horse's calorie needs. There is some fairly recent research that I believe this was published in 2022. And in this research, they fed metabolic horses. These were obese, sedentary metabolic horses. And they looked at the glucose insulin response to different levels they were feeding some pure starch and some pure sugars. And they found that these metabolic, obese, sedentary horses had very large glucose insulin responses to the amount of NSC in a meal. So for very, very sensitive horses, we have new recommendations of even lower NSC for these insulin dysregulated horses. And that is all the way down to 0.1 grams per kilo body weight per meal. And then you see all the way down at the 10% NSC, you're looking at no more than about a pound of that low NSC feed per meal. But again, these are obese, insulin dysregulated horses. My recommendation is if you've got a horse that is this sensitive, it should be on a program of a low NSC hay and then a ration balancer. And hopefully if these horses are not laminitic, they can be exercised. And quite honestly, the herd of horses that were used for this research, they did not trigger laminitis with these levels of NSC. Even in these obese, metabolic, sedentary horses, they did not trigger laminitis. They just saw a glucose insulin, a very exaggerated glucose insulin response. So again, for these horses, I would say get the weight off, get them exercising, and see if you can get them so they are more insulin sensitive, because there has been good results reported with exercise and getting weight off and seeing some of these horses becoming more insulin sensitive. From the same group of researchers, there was even more recent research looking at the insulin response to forage pellets. And you can see the bars that are circled in red. For these insulin dysregulated horses, they fed some low NSC pellets, pelleted timothy, pelleted alfalfa, pelleted timothy and alfalfa, and then oat groats. And oat groats are going to be very high starch. So the big black bar on the right would be the oat groats. There was an exaggerated insulin response to the starch in the oat groats. But as you see and these are in the insulin dysregulated horses, the response to the hay pellets was much lower. Now, the insulin response to the hay pellets in the insulin dysregulated horses was still higher than the healthy horses, which is the NID, which is non-insulin dysregulated horses. It was higher, but that's actually, in reality, that's still a very low insulin response. So the thought from this research is that for insulin dysregulated horses, feeding hay pellets may be a good option that does not create a hugely exaggerated glucose insulin response. If you're dealing with a very sensitive horse, should you have a forage analysis on your hay? And possibly yes, because you are going to find the NSC if you have a good forage analysis. You need to be sure that the forage lab actually analyzed the hay sample for WSC, which is water-soluble carbs, and that in general is the sugar and the fructans. And you want ESC, ethanol-soluble carbs, which is primarily sugars only, but it appears that that assay actually pulls out some short-chain fructans, but it gets you mostly the sugars. And then you want the assay for starch. For NSC, you usually add WSC plus starch, and that will give you the NSC in your forage. And the ideal NSC is less than 10 to 12% for horses with metabolic syndrome. Keep in mind, every horse is an individual, and some horses are more sensitive than others. If you've got a metabolic syndrome horse and it struggles with laminitis, then you want to stay below the 10%. If you've got a horse that you suspect is metabolic, tends to show some regional adiposity, some of the other signs of metabolic syndrome, you are probably okay going up to maybe 12%, but it's something to be aware of. And keep in mind, you can always soak your hay and reduce the NSC. Alfalfa is often quite low in NSC. The problem may be excessive calories for obese horses. And analysis can be important for horses with metabolic syndrome because NSC in hay is quite variable. It really has a lot to do with how the hay was harvested and the maturity of the plant when it was cut. So even though you stay with the same kind of hay, different batches of hay can be very different in NSC. If you have a highly sensitive horse, if you can get your forage analyzed, it can be very helpful. And when you sample for forage analysis, the best thing to do is have a probe. So you can use a hay probe in your bale of hay, randomly choose 12, 20 bales, probe from the center of the small end between the strings, get pretty deep so you get a good representative sample of the bale. Put all the samples into a plastic bag and send the final sample of about 3/4 to a pound. I usually recommend Equi-Analytical or Dairy One for when you're wanting to do forage analyses and get good numbers for NSC. So there are some other labs that do a nice job, but if it's really important, if your horse is very sensitive, it may very well make sense to get your forage analyzed. And this is what you're going to see. This is from Equine. And I've got in a blue circle, that's where you've got the WSC, the ESC, and the starch. And again, you would add the WSC plus the starch in a forage, and that's going to give you your total NSC. Prevention. Focus on maintaining normal weight in horses. That's just such a big one, particularly the high-risk breeds. And these horses often are very efficient users of calories. Those are the easy keepers, and it's imperative to feed appropriately to maintain an ideal body condition score and not let them get obese. You want to control the amount of soluble carbs. If you have a horse that's at risk of metabolic syndrome, again, if you've got a horse that's healthy and exercising and it's a breed that typically doesn't have any problems with metabolic syndrome, then you don't usually really have to worry about soluble carbs. But you do, if you've got a horse at risk of metabolic syndrome, you want to match an appropriate product and recommended feeding to meet the needs of that horse. Regular exercise is a very important part of keeping insulin dysregulation in check. Maximizing turnout for free exercise can be extremely beneficial, but of course, you got to think about what kind of pasture you've got going on. And for some of these horses, maximizing turnout by having a big dry lot available can be your best friend. And the last thing I'm going to talk then about is pituitary pars intermedia dysfunction, or PPID, which is commonly known as Cushing's disease in horses, but it's not called that anymore because Cushing's in humans is a very different thing than Cushing's in horses. So now it's pituitary pars intermedia dysfunction. And it is hypertrophy in the pars intermedia of the pituitary gland, which is an excess cell proliferation. It's an endocrine disorder. It occurs in more than 20% of aged horses. We found PPID in horses as young as 10, but below 10, it is very unlikely. And from 10 to 20, it's not a typical thing to have happen. But I had a 14-year-old thoroughbred mare that had PPID back about a decade ago. So it's not unheard of. But these are benign tumors, and they cause overproduction of hormones that create an abnormal metabolic state. And one of the main hormones that's overproduced is the ACTH, adrenocorticotropic hormone. And what happens with an overproduction of ACTH is delayed shedding, hirsutism, which is that big, heavy, sometimes curly or wavy hair coat that we tend to see in PPID horses, muscle wasting, weight loss, increased drinking and urination, abnormal sweating. Sometimes that's an increase in sweating, sometimes it's a decrease in sweating. You can see behavior changes, reproductive abnormalities, and immune suppression because these horses tend to have frequent infections. And the picture that I have here is my old man Boo that I lost last year at the age of 37 and a half, and you sure cannot tell from this picture, but he was blazing PPID. So I have several pictures of Boo to show you my own PPID example. And this is Boo again, and this is Boo when he had not been body clipped. So again, the heavy hair coat is a typical symptom of PPID horses, but not always, because it is a tumor that's on the pituitary, and so you cannot say for sure what symptoms, what signs are going to occur from this proliferation of cells in the pituitary. Some testing and typical signs that are used for diagnosis is the basal ACTH concentration, just to kind of see where it is, because sometimes the PPID horses have a higher ACTH concentration. Then thyrotropin releasing hormone stimulation test and overnight dexamethasone suppression tests can be used when there is just a suspicion of PPID. It's hard to really thoroughly diagnose PPID, and often it's just based on the symptoms. With Boo, the first thing that And honestly, about the only symptom Boo ever showed was the big hair coat. He never developed laminitis. He was not insulin dysregulated. He just had a big, thick hair coat. And so I dealt with that. However, a number of PPID horses do exhibit insulin dysregulation. Again, not all of them. A researcher, Diane McFarlane, who did a great deal of work on PPID horses, and this was several years ago, but at that time I was at one of her lectures, and she estimated that only about 30% of PPID horses also had insulin dysregulation. So just because a horse is diagnosed with PPID does not mean that you are also dealing with insulin dysregulation, which I was very lucky I did not have to. But if you do suspect insulin dysregulation, then you'd want to have the veterinarian test resting glucose and insulin levels, sometimes an oral sugar test or an insulin tolerance test. There are some tests to give you an idea if the PPID horse is insulin dysregulated. So to manage PPID, you absolutely want to work with your veterinarian. There is a medication, pergolide mesylate, that acts on receptors in pars intermedia to help suppress the tissue enlargement and tumor growth. And many horses, you put them on pergolide and it does reduce their symptoms. I will just flat out come out and tell you at 37 and a half, I never did put Boo on pergolide because he was not insulin dysregulated. We body clipped him to manage his hair coat, and he didn't have any other problems. And he was sound and healthy until the evening that he went out to pasture and passed away in his sleep. He gave a riding lesson that day before he passed away. So PPID, it can be tricky because you have to deal with whatever the pituitary is affecting. And it can be just a few things. It can be many major things. And laminitis certainly can be a problem with PPID. So again, work with your vet, work with medication, and then wellness care with dental examinations, parasite control, vaccination, all these things to keep these guys healthy, because remember, they're aging, and with PPID, often their immune systems are suppressed. And then nutritional management, depending on if you're dealing with an insulin dysregulated horse or not. So if they are insulin dysregulated, you want to use the same weight management protocol, pasture restriction and or a muzzle, low NSC forage, soaking the hay, appropriate feed, pretty much all the same things that you're going to do with the metabolic horse. One thing that I do want to make sure, especially with the PPID horses, because muscle wasting is also a symptom, you want to make sure that they have adequate protein in their diets to support muscle, just muscle health, and reduce the muscle wasting as much as you possibly can. If you do not have insulin dysregulation, so normal insulin management, as you see, this is Boo, and he was about a quarter of the way through his body clipping, which happened in the summer. He got body clipped about every 5 to 6 weeks because he kept growing that massive winter hair coat even in the middle of the hot summer. But weight management protocol, pasture access with vigilance. Boo did go out on pasture every summer. Actually, he got turned out on pasture year round, but he was not insulin dysregulated, and I watched it like a hawk. Controlled NSC feed kind of depends on your horse's sensitivity. Less than 18% on a dry matter basis, maybe. Again, it depends on the individual. I would say Boo, by the time he was in his mid-30s, he had about 3 teeth left. So he was on a total complete feed diet because he would pick up the hay and kind of chew on it and get nothing done. But his total diet was probably 22 to 25% NSC. Again, he was not insulin dysregulated, and I watched him like a hawk. Possibly a protein supplement for muscle support. Make sure you are getting adequate amino acids for these older guys. and then possibly dietary fat for additional calories, because a lot of times the old PPID horses may be really hard keepers. And part of that may be because they're geriatric and they have poor dental condition. If this is the case, you got to maintain adequate fiber to supply calories and maintain a healthy gut. And if their teeth are so bad, they're not eating hay well. And some of them, Boo got to the point where he didn't even utilize green grass well. So you got to make sure that they're getting adequate fiber from another source, such as hay pellets, again, appropriate NSC of the hay pellets, plus if it's an easy enough keeper that you can deal with hay pellets, a ration balancer, or if they're not an easy keeper, a concentrate feed, or pelleted forage alternatives such as hay stretcher, pelleted beet pulp, etc., plus again, ration balancer or concentrate feed, or a formulated complete feed that is a feed designed for horses with dental conditions or situations where there are not good forages available. And just make sure that your horse is getting all the nutrition it needs. The maximum tolerable NSC varies, possibly less than 18% of a geriatric horse. If it's an insulin dysregulated geriatric horse, then we're probably looking all the way down to the 10 to 12% again. And again, I keep harping on this to ensure high quality protein sources. I have seen so many horses that in the effort to reduce NSC, the protein is also reduced. And so they lose even more muscle mass than they would need to in the situation. So that is all I have. I thank you very much for your time and attention, and apologize for all our issues at the beginning. But if there are any questions, I would be more than happy to entertain them.
We have a few questions. I guess I want to start first, go back and reiterate something that I think a lot of people are confused on, or people that I talk to. So this, you read it in articles all the time. There's a couple of things here. So I'm going to go to two questions. But the first one is this, 10% NSC. You do sometimes see the 12%, but 10% NSC. But I think people think that the total diet needs to be 10%, below 10% NSC. And a lot of people don't understand per meal. And you touched on it a few times, but could you reiterate that?
Yes, and that's back to that chart with when you're the 10 to 12% NSC is primarily, that's in the forage, but in the concentrate portion of the diet, it depends on the amount. And that's when we go to, depending on the situation, is it a very, very sensitive, obese, sedentary, metabolic horse that is just on the verge of laminitis, or it's chronically laminitic? Then I'm going to be looking at the 0.1 grams per kilogram body weight per meal. Right. So then you have to look at what you are feeding. And again, if you've got an 1,100 pound horse, then you're feeding maybe a pound at most of a 10% NSC meal. But if you've just got an insulin dysregulated horse, then we can go back to the 0.3 grams per kilo body weight. So then you can be feeding a 15% NSC meal. You can be feeding a 17% NSC meal. Yeah. You've got a little bit more wiggle room there. And again, at the 0.3 grams per kilo body weight, you can feed 2 to 2.5 pounds of a 17% feed. You can feed 3 pounds of a 15 or 10% NSC feed. So it's all about how sensitive your horse is and how concentrated the NSC content is in that particular feed. Right. And I also want to point out once again, these are metabolic horses. Healthy horses Healthy
And
horses are a whole different deal.
they can
And then
tolerate. They can
they can
tolerate
tolerate.
BS. Yeah.
And I have heard, I've heard it reported that, starch and sugar are not natural for horses. Oh, yeah, it is. Starch and sugar is very natural for horses. Mare's milk can be like 60+% sugar. So babies are getting lots of sugar in their meals. And then when you think about when horses we had the wild horses evolving out on the grasslands, grasses go to seed. And those horses are eating the seeds.
Yeah.
And seeds are high NSC, and they like the seeds. And they prefer the grasses with the higher NSCs. That's what they go for. But those are healthy horses. They're not obese. They're moving. They're exercising. So that is the big take home that I would like everybody to, kind of keep with them. That if you've got a horse that is, you maintain them at a body condition score of 5 to 6, regular exercise, you avoid obesity. Even horses that may be genetically predisposed. And I had a herd of lesson horses. I had horses that if I'd let them, they'd have been metabolic.
Mhm.
And I just was going, nope, you're not going to get fat and you're going to keep exercising.
Yeah. Yeah. I think there's a lot of confusion out there from what you hear and what you read. And people seem to be stuck on this 10%, but they think the feed, that like the general NSC of that feed has to be below 10%. And
Yep.
when I try to explain to them about the amount per meal is more important to look at instead of the percentage on the bag. But
Yep.
it is confusing for people because when you read an article or you hear something, they don't go into the nuances and
Yes.
explain all that or the highs and lows.
Yep.
The other thing that we hear every once in a while is it's sort of a new trend of the protein, and the protein, high protein diet can cause insulin spikes. And
Yep.
you want to address that?
I'm aware of that as well. And it is true that there are some amino acids in proteins that are gluconeogenic, that the body can take a specific amino acid, and in the liver, it can use that amino acid and convert it to glucose. And yes, insulin is involved in the metabolism of protein, but the protein has not been proven to cause the glucose insulin spikes that we see from the dietary NSC. And I believe that there was some research, I think it was in 2019, and it was conducted on the same herd of metabolic, sedentary, obese horses. And they were looking to see, because that thought has been there. 20 years ago, 25 years ago now, I was a little worried about feeding a 32% ration balancer, 32% protein ration balancer to these very high risk horses, because were the amino acids going to be causing a glucose insulin spike? And there was some research presented back when I was still really worried about it. And it was presented at the Equine Science Society meetings, I believe, in a poster. And they did feed a pound of a 32% ration balancer to healthy horses. And the glucose insulin response was no different than giving them like a flake of grass hay. It was just really not of concern. But I think where the current concern was, again, in 19, there was a research study, and they were trying to see what happened with the glucose insulin response in metabolic horses. So they fed basically about 4 pounds of a rate of 4 pounds for a 1,000-pound horse of ration balancer. I believe it was a 31% protein ration balancer over a period of like a total of 30 minutes, which that's a lot of, that's 4 pounds of 32% or 31% protein. And they did see in these insulin dysregulated horses, they did see this very exaggerated glucose insulin response. So the conclusion was, okay, maybe protein is a concern. But if you actually read that paper, the ration balancer they fed was 15% NSC. And when they went back, the next research that was done with this herd of horses was Erica Macon's research that fed that indicated that 0.1 grams of NSC per kilo horse was where you needed to be to reduce the risk of the exaggerated glucose insulin response. And if you take those numbers and compare the 4 pounds of 15% NSC was a much higher level of NSC than that threshold of 0.1 grams per kilo body weight. So there's confounding there. Was that exaggerated glucose insulin response due to the protein or to the NSC?
Right.
And so unfortunately, nobody that I have found yet has done research that isolates just feeding high protein without the NSC. Right. So at this point, and I have looked for research and I have not found anything beyond the 2019 paper that really indicates that protein is, a big scary thing for insulin dysregulated horses. But also keep in mind that if you've got a hugely sensitive horse and you're really worried about it, even with the ration balancer, split it up into smaller meals, because a smaller meal also will reduce the glucose insulin response.
That's the key piece right there.
Yeah.
Okay, I better start reading some of these questions. One of them was from a while ago, like back in the slides. The lower NSC in hay I could find the last 10 years is 12 to 13% on DM basis. Is it really possible to find lower than 10% NSC in forage?
It is. And the hard thing is,
and it's called TEF.
Well, actually, TEF is also highly variable in NSC. Yeah, but when you start getting down into those lower NSCs, the warm season grasses are going to be the best bet. Alfalfa is often lower than 10% NSC. But when you're getting into the grass hays, especially the cool season grass hays, to get that low of NSC, the plant's got to be pretty mature when it was cut, which means it's a lower quality hay in general.
Yeah.
So it is tricky when you're trying to reduce the NSC. And my recommendation is, if you've got that really sensitive horse and you're really trying to minimize the NSC, soak the hay.
Yeah. It's a good one. Okay. I don't know if we've just lost everybody. For a pony with chronic ulcers and needs to keep food in his belly, some vets recommend feeding straw for most of the day, spaced with soaked hay cubes. 2 to 3 meals a day to keep short stem fibers to control diarrhea.
Yeah, I have seen that recommendation. If you have a source of high quality straw, that may be an option. I'm in Kansas. In the US, it's hard to find high quality straw, so it's not something that I tend to recommend. I'm probably more prone to say get some sort of slow feed hay container, either a very small whole hay net. I personally have become a big fan of hay pillows, anything to just slow down the intake.
Yeah.
I've even seen people that will get a slow feed hay feeder and put the hay inside the slow feed hay feeder in a small whole hay net. So just to slow them down. But yeah, in places where high quality straw is available, that can be an option.
Yep. I've even used that.
Yeah.
Okay, next. Why do some say that you should add the ESC and starch to get NSC? I find there are differing opinions on that. So we've
Yep.
had this discussion ourselves.
Yep.
It seems to be continuous across feed companies use ESC plus starch.
Yep.
So do you want to touch
That
on
is
that?
true. The research is based on WSC plus starch. Feed companies, and yep, I've got to admit, as when I was in charge of all the horse feed labels, we used ESC for sugars because remember, ESC is primarily sugars and short chain fructans. WSC is sugars and all the fructans. We don't have good analyses that measure the physiological fractions of forages or feeds. These are analytical fractions. So when I am looking at a horse that is prone to laminitis due to a soluble carb overload to the hindgut, then I want to look at WSC because that's got the fructans. When I am looking at insulin dysregulation, I'm going to use ESC because fructans don't really elicit an insulin response because remember, those are fermented in the hindgut and they're not broken down into glucose. So you're not getting glucose in the bloodstream to stimulate that insulin response. And in feeds, at least in the US, the labeling on feeds, when there are carb claims made about the feed, then AFCO requires that maximum starch, maximum sugars, and maximum fructans are on the label, but only maximum fructans if it's a forage, basically a forage ingredient.
Right.
Because grains aren't going to have fructans.
Sure.
And so the typical feeds are not going to have much fructans. But if you, again, are dealing with a horse that gets laminitis due to soluble carbs in the hindgut, then I am absolutely going to look at fructans. But again, that doesn't help you when you look at the research because historically the research defines NSC as WSC plus starch.
Right. I think that was a great explanation. I hope the lady that wrote that in got that. Hope she's still on here. Next one was, could EMS happen to young horses? If so, the IR feeds are usually low in protein. Would you supplement with anything?
That is really a good question, and that's something that would really be a case-by-case basis to me. If it's a young growing horses are much less likely to exhibit any signs of metabolic syndrome. And hopefully in time, we're going to have a better understanding of genetics. But if you've got a young growing horse, again, I would watch that body condition score and make sure they don't get fat. And actually, if it's a young growing horse, the other thing that happens if your young horse gets fat, that may mean it's not getting adequate nutrients besides calories to support healthy growth.
Right.
Because if they're getting fat, does that mean they're deficient in protein? So, because if they're deficient in protein, they're not going to have the nutrients to grow. So for a young horse, even if it's a breed that is typically prone to metabolic syndrome, I wouldn't let it get fat, and I would keep it on a feed to support healthy growth.
Yes.
And yes, so if you get a really low NSC feed that's not got a good amino acid profile, no, that's not going to be a good way to support growth.
No, because young growing horses need carbohydrates to grow. I think that's important. And I hope that there's not a trend of that message getting out to people that young growing horses should be fed very low NSC feeds. I hope that's
Yeah.
not out there.
Yeah.
I'm not seeing much of it, but yeah. The next webinar is on breeding, so I'm sure we'll cover that in the next one.
Yep.
Okay, next, because we're moving on here in time. Do you have to watch protein for an insulin-resistant horse? I was worried about protein in my laminitic prone horse, so we sort of already covered this.
Yep.
Do you want to touch on that again, or?
I'd just be reiterating the same thing that that because protein is an essential nutrient, and you starve the horse of essential amino acids, and you're going to affect all sorts of functions. You're going to affect the immune system. You can affect the bone health. You're certainly going to affect muscle health.
Yeah.
So I'm not going to go wildly throwing protein at them, but even the ration balancer, if you're feeding 1 to 2 pounds of a 30%-ish protein ration balancer, you are still counting on the forage to provide the majority of the protein to meet the daily requirements. So yeah, I'm not going to want to starve a horse of protein. You might need to do a ration evaluation and make sure that it's meeting its protein requirements.
And I think, again, back to that question is, watching the amount. So even if the horse is just getting a ration balance, or splitting up those meals to have the NSC even lower amounts, even if it is just a ration balancer.
And again, in there's research out there, published research, that the same amount of NSC in a smaller meal actually had a low, it's by grams, it was the same amount of NSC, but it had a lower glucose insulin response.
All right. Okay, next question. What is your opinion on spirulina and jiagulan?
They're interesting ingredients. There's not anything really magical. Spirulina has got some marine-based omega-3s in it.
Yeah.
So I think there are more balanced ways to get marine-based omega-3s. It's one of those things. I don't think it's magical, but I don't think it's hurting anything. So
yeah, there's a lot of supplements out there that are that range.
And that kind of gets in. I'm not going to get into the whole, can of worms of supplements, but when you start looking at the supplements, look for the published research. And look for the published research on the efficacy of that particular supplement, because there are a lot of websites that say there's research on this ingredient, there's research on this ingredient, and you have no idea how much of that ingredient is actually in the supplement, if it's even an effective amount. I was looking at one not too long ago, and it said, there is published research on this. And, I clicked through and finally found the research, and all the research said was they fed it and it was safe.
Mm-hmm.
Yippee. I don't want to spend money on something that's not doing anything.
100%. And we could do a whole talk on.
Oh, yeah.
On that. Okay, next. What happens if you treat a normal horse like an EMS horse? Can not having much NSC be bad for a normal, easy-keeping horse?
If it is just a sedentary pasture ornament, low NSC is not going to hurt anything. If you're looking at any kind of performance, work performance, breeding performance, growth, then yeah, you get too low NSC. And remember, the glucose from the NSC is the primary fuel for the brain. It's the only fuel for the brain. It's the primary fuel for the feet.
And for the muscles.
It refills. That's the source of substrate for the glycogen. So if you've got a healthy horse, if you're looking at, just kind of the low NSC feeds of 12 to 16, 17%, that's not going to be any problem unless if you've got a race horse, your horse is not going to be able to run on that low NSC. it's the horses, it's the healthy horses that have something expected of them that are on those feeds that are less than 10% NSC. And the sad thing too is a good quality feed that is that low in NSC is not a cheap feed, because those high fiber, low NSC ingredients are more expensive. So that's my TED Talk there.
Okay, the next question is actually for me as Brooks. But from the Brooks line, is there a recommendation on grain for a laminitic pony, insulin dysregulated on 10% NSC hay, but needs calories, using a free choice mineral as well? Okay, so I'm going to suggest to this person, I'll write it in the box to reach out to me. So I'm going to put my email in here. But anyone who has any questions can email me at lbishop@brooksfeeds.com. We do have a low NSC feed that doesn't have any grain in it, that is not a high calorie feed called FiberLite. So we do have something available. But again, depending on the horse and many other questions that I'm going to ask, you may not need that lowest NSC feed. Maybe we can go to something in that 16 to 18% NSC feed. Again, many questions to ask. So
you start with, tell me about your horse.
Tell me about your horse.
Yeah.
and I sometimes apologize to people ahead of time. So I'm going to ask you a lot of questions.
Yep.
To find out all the little nuances that we need to get into
absolutely.
Into the
weeds. You got to have all the puzzle pieces to put it together so you have the whole picture.
Yes. I think that's it. We've got, I'm really pleased to see there's still lots of people on here.
Sure, appreciate people for hanging in.
Oh yeah, really appreciate it. We'll try not we'll get on super early next time to weed out the technical problems. But the next one is on breeding. That should be a great webinar as well. And I think that's a month from now. So everybody will get a recording of this. So it's recorded. We send out the recording. So for those who had to come, get off early, it's all there. So thank you very much, everyone. Thank you, Dr. Young.
You're very welcome.
Pleasure. And I think we'll be talking to you tomorrow.
Sounds good.
Thank you, everyone. Have a good night.